boys and girls. This is Mrs. Atkinson. Today we are going to be starting topic 11, which is line plots. You're going to need two things for today's lesson. First, it's your math notebook if you have it at home. If you don't have your math notebook at home, a simple piece of paper will do for our notes today. And then the other thing that you need to have out is your math workbook. We are going to be starting topic 11, and we're going to be on page 588. So this is the page here. I'm going to write the number on the top, page 588. We're going to be using page 588, and then we're also going to be using the purple word cards that are associated with this topic. There's only two words to know, line plot and outlier, and we're going to be talking about those as well today. So make sure that you have everything you need, a piece of paper, some markers, and your math workbook. Pause this video and go get those things, and then come on back. All right, the first thing we're going to do together today is take one page of notes. So I'm going to just open up my notebook to the next blank page, and you should do the same. If you're just doing a piece of paper, that is fine as well. All right, so we are on topic 11, which is line plots. I'm going to make a nice title here. Let me just rearrange myself a little bit. Okay. I want to write down line plots and maybe topic 11. This isn't a very long topic. It's a pretty short topic. We're going to be spending about a week and a half, maybe 2 weeks on it in all. And just to make it a little bit fancy, so we like to look at our notes. All right, so the first question I'm sure everyone has is, what exactly is a line plot? So we're going to write that question first, and then we're going to answer that. So what, and you should be copying just like I am, is a line plot. If I'm moving too fast, you can always pause the video. All right, so what is a line plot? Well, a line plot is simply a way to display data or information, and it's used, a number line is used to do that. So I'm going to write a line plot is a way to display data on a number line. That's it. All right, I'm going to make this a little fancy here. We're going to underline line plot. And I also want to underline the word data. So data is any information that you gather. The fun part about this topic is that you're going to get to survey lots of people and find out information. On Friday, you're even going to get to create your own line plot. So we're going to really be keeping in mind what data means and the different ways that it can be represented. On a number line in particular, each dot, and let's write this down too, each dot, or sometimes we just make an X instead of a dot, so I'm going to put those in quotations there. Each dot or X represents one number in a set of data. So that's really all you need to know. So what does a line plot exactly look like? All right, well, let's do an example. It's best illustrated using some kind of an example. So let's say, you can hear my dog barking in the background. Let's say I wanted to survey like a bunch of people and find out how many pets they owned. So I might ask this question: how many pets do you own? And that could also be maybe the title of my line plot. It might be pets or pets owned by people, something like that. So that's my example. So here's what that might look like on a line plot. I just draw like a regular kind of a number line. And let's say I asked 10 people. And let's see. So these down here would be my number of pets, right? All right. And I asked 10 people. So these are the pets here. Okay. And let's say I had 2 people that said they had no pets at all. So I'm going to indicate those 2 people by making X's above the 0. So 2 people had no pets. There were lots of people, actually, 4 people that only had 1 pet. So I'll put those 4 X's there. Okay, I am in the middle of making a video. Can you go ask Daddy, okay? Go. He's sleeping on the couch. I know. Can you believe that? But I'm not stopping this video. All right. I'll give you your laugh for the day. All right. There's nobody that I surveyed has 2 pets. And I don't know, maybe one person I talked to had 3 pets. That's pretty cool. There were 2 people that have 4 pets. That's a lot. And then there was this one person that had 9 pets. Can you believe it? Wow. I wonder how many pets you guys have. So these were my 10 people. Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So I asked 10 people how many pets they had, and they told me. And now I'm just using my line plot to kind of organize my data. The cool thing about a line plot is that it gives you immediate information. So I can look at this line plot and really kind of know a few things right off the bat. It's pretty easy. One thing I noticed right away is that the most number of pets, like the most common number of pets that people have, is 1, right? I know I have 1. I have my dog Stella. So that's the most common. The least common, besides having no pets at all, I guess the least common was 3 pets. I also noticed that there was this guy out here, right? Look at that. This person owns 9 pets. And look at how far away that X is from the other red X's. There's a special name that we call a data set that is very different from the rest. And this is called an outlier. And that is actually one of your vocabulary words. Right? It's very different from the rest. Very different. And that's why we call it an outlier. I kind of think of it like an outcast, right? Someone who's really, really different. All right. Another thing that's a common question that people usually ask, they'll say things like, besides what is the most common, what is the least common, they might say, what is the difference between the greatest number of pets owned and the least number of pets owned? So you'd have to go 9 minus 0, and that would give you 9. So 9 would be your difference. They also might say, like, how many pets are owned in total? And if they asked you that, let's see, that's nothing, right? But I have, let's see, 1, 2, 3, 4, 5, 6, 7. And then this would be like another 8. So we'd have 7 plus 8. And then 9. And if we added that all up, let's see, we have 4, because we have 4 here, plus 3 pets there, plus 8, plus 9. And if we add that all up, we would get 24 pets. So that would be another answer. Could be like, what are the total number of pets owned, right? So we can use our line plot to answer lots of questions. So your page of notes should look like mine. If you need to go back and you need to pause it, I'll try to get a little one shot there for you. You can certainly do that, but I might even ask you to hold up your notes on, either take a picture of them and hold them up, or you can showcase them at the end of our topic, perhaps on a Flipgrid. So you are responsible for making sure that these notes get taken down. All right, guys, we're moving on now. We can kind of set our notebook aside, and we're going to move on to our math workbook page. So first thing, let's take a look at the workbook page that is purple word cards. It's 589. And you're going to see that there's only 2 words for this topic. I'm going to zoom in on them. Line plot and outlier. And now knowing just what we know, we can see that this is an example of a line plot. And we see that with this data set here, there's one outlier. There's one dot that is far away from everybody else. So our outlier would be right there. Right. In turning this over, and if you want, you can cut out your cards as well. Let's do this. A blank is a way to display data along a number line, where each dot represents one number in a data set. The answer here is line plot. So fill that in. Any number in a data set that is very different from the rest of the numbers is called an outlier. All right, done with our word cards. Now let's take a look at page 588. Everybody should be on this page. You should have it out in front of you. You should be filling it in as I am going through it. This page is a review in what you know, but it really is going to be very helpful for us as we move into this next topic because we've been away from fractions a bit, and line plots is really going to bring that information back for us. So let's figure out what some of these vocabulary words that we would fill in are. We know this one. A blank is a way to organize data on a number line. So we know that that is line plot. So we're going to fill that in. Okay, number 2, numbers that show the units used on a graph are called a scale. Okay, so we did scale. And number 3, blank are pieces of information. Well, I think we know that it would be data. Data are pieces of information. So the only word that we didn't use was compare. But now we're actually going to compare. Let's take a look down here. Whenever we're comparing fractions, we know that we can't compare them if they have a different denominator. And if you look at all of these fractions right here, we see different denominators. So there's a few choices that we have. We can get a common denominator. We can think about the fraction, like maybe compare it to a benchmark or something that we're familiar with, or we can use our cross multiplying or butterfly method to compare them as well. So let's try a few different ways. I have 7/8, which is almost 8/8, which would be a whole, right? And then I have 3/4. Well, 3/4 is almost 4/4, so that's almost a whole. So thinking about it might not be the best way to decide for me. You know what? I'm looking at these denominators, an 8 and a 4. Maybe I'll just get a common denominator. I think I'm going to use 8. So instead of the 4, I think I'm going to do an 8. How did I go from a 4 to an 8? Well, I multiplied by 2. So now I have to multiply my top by 2. So 3 times 2 is 6. Now that I have a common denominator, 7/8 compared to 6/8, I can clearly see that 7/8 is greater. All right, let's take a look at this guy over here. Here we are comparing 1/2 and 5/8. Now, I might be able to say, well, 5/8, well, half would be 4/8, and it's 5/8. So I'm thinking that 5/8 is going to be greater, but let me just test it out. Maybe I'll use my butterfly method for this. So I have 2 times 5, which would be 10. And if I multiply this way, 8 times 1 is 8. I know 10 is greater than 8, so therefore 5/8 would be greater than 1/2, just as I suspected. And let's do this one over here. So we have 1/4 or 2/8. Well, maybe I can get a common denominator here. Let's see. Let's get a common denominator of, well, let's do 8, I guess. So 4 goes into 8 2 times. 2 times 1 is 2. Oh, look at that. 2/8 is actually equal to 2/8. Therefore, 1/4 is equal to 2/8. This is bringing back some memories for you guys in our fraction unit. All right, and this is worthwhile because this is the type of things that we're going to be doing in this topic as well. All right, our favorite thing to do, subtract mixed numbers. You're actually going to be doing a lot of this with line plots, so it's really important to familiarize yourself with how we did this. And we learned this back in our fraction topics. All right, so we know that we have to have a common denominator to add and subtract fractions. And I look at all of these and I'm getting really, really happy because look, they have a common denominator already. So that's good. Big sigh of relief. All right, well, let's take a look. So 10 minus 4, I could do the whole numbers first, right? 10 minus 4 would give me a whole number 6. So far, so good. And now I'm going to subtract my numerators. 3 minus 1. Oh, good, it works. It gives me a 2. And I'm going to pull over my same denominator, and I'm going to get 6 and 2/8. If I wanted to reduce that, I could, but you don't have to. 6 and 2/8 is fine. So that one worked out pretty nicely. But the next one might not be working out so nicely. Let's take a look at it. So I could do 5 minus 3 and get 2, but oh no, but look, when I would do 1 minus 3 as for my numerators, I can't take 3 away from a 1, right? That doesn't work. So do you remember that we learned in school that what we can do is take 1 away from our whole? So instead of 5, I'm going to pull 1 out of that. So I'm taking 1 away, leaving me with 4. Now that 1 that I pulled out, right, I'm going to change that into 4/4. Why 4/4? Because 4 is my denominator. So I'm going to take that 4/4 or whole that I pulled out and I'm going to put it back into the numerator. So 4/4 plus 1/4 would be 5/4. Okay, now I can copy down what I had there before, and now I can work it out. 4 minus 3 is 1 whole. 5 minus 3, see how it works now, is going to be 2, and I keep my same denominator. So my answer is 1 and 2/4, or I could do 1 and 1/2 if I wanted to reduce it. All right, that was like the hardest kind, I feel like. All right, the next guy, we have 7 and 4/8 minus 2 and 4/8. We got this. 7 minus 2 is simply a 5, and 4/8 minus 4/8 is 0/8. And we actually don't even have to write that, right? So really, it's just 5 as our answer. All right, last part of our video today, we are going to actually take a stab at interpreting some data. So they give us some data. It's over here in a data table. They're talking about snakes, which is my least favorite animal, I must admit. And they want us to answer some questions about it. So the first thing you should always do is just familiarize yourself with the data table. It's a few minutes worth, well spent. So I have a 12.5-inch snake, a 16.5-inch snake. Oh, that's not so good. A 17. Oh, there's 2 17s. Actually, there's 3 16s. Oh, like 2 12.5s. Oh my gosh, there's a snake that's 24 inches long. That looks like the biggest one out of all. All right. So I just kind of looked at that a little bit, got familiar, and now I can answer some of the questions. What is the greatest snake's length? Oh, that's easy. Remember, that's the 24 guy. So I'm going to say 24 inches for that one. What is the least snake length? Like the lowest amount? Let's see. The least one, I guess, I was going to say 13. Oh, no, 12.5 seems to be the least, right? 12.5. Okay. Which of the snake lengths are recorded more than once? All right, well, let's see. There are, how many of the 16s? 1, 2, 3. So there's 3 16 inches. There's, let's see, 2 17s, right? Let's see, I'll put a little box around them. 2 17s. 2 17 inches. And let's see, there was another one that repeated too, right? Let's see, 12.5 and 12.5. So there's 2 12.5s. And I think that was it, right? Those were the repeats. Okay. Which length was recorded the most? Well, there was 3 of those 16 inches, right? So the most would be the 16 inches. There was 3 of those guys. And now they asked me another question. This one, I'm going to put a little star next to it. This is like the favorite question ever for people who create these line plots for us. They love to ask you, what is the difference between the greatest and the shortest, or the most and the least, or however it applies to their line plot. So we can do that. The greatest length here was that really long snake, which would have been 24 inches. Ooh. And the shortest snake, we said up here, right? It was 12 and a half. And now we have to actually subtract, right? And when you do that, you're like, oh, wait a minute. I don't have a fraction part to subtract. So one thing that you can do is take 1 away from 24, making it 23. And then we're going to put that whole back in as a fraction. That 1 that we took away, we're going to make it 2 over 2. You can see how 23 and 2 halves is the same thing as 24, because we know 2 over 2 is equal to 1, and 23 plus 1 would be 24. And now I am able to subtract. So 23 minus 12 would give me 11, and 2 minus 1 would be 1, and I use my same denominator, leaving me with 11 and a half inches. So there we go. In this topic, we're going to use data. We're going to be creating line plots. We're going to be analyzing line plots, interpreting line plots, everything line plots. It's quick and easy. I think you're going to like this topic, and it has a lot to do with our knowledge of fractions. So join me next time for more on line plots. Have a great day, everyone.